Hi everybody and welcome to part 4 of Let's Code a Networking Stack. In this video we're going to write the protocol manager object that we saw in the previous video, and hopefully this should allow us to move the packet objects in and around the protocols that will register with the protocol manager. So I already have some boilerplate that I've already written. Protocol.h, basically we have forward declared the packet object, and we also have an enumerator for the different kinds of protocols. So this is the, if you remember in the last video we had a handler object. This is essentially the things, the values that the handler will take is a value from this enumerator. So we're going to also now type def a function callback type, which is going to be, so that's going to be the sort of the type of the function callback for the TX and the RX functions that each protocol is going to implement. So now the main event is the protocol underscore T. So this represents a protocol in the networking stack. We're going to have, so that's the type of protocol. So it, you know, again, it might be Ethernet, ARP, whatever. We will add an appropriate value to the enum that will marry up to the protocol type here. So those are our TX and RX callbacks. Have a name as well that it can give, and also we chain them together with a list. So that's our protocol list, or our protocol structure. We'll add a quick helper that allows us to enumerate through the protocol, the list of registered protocols. Protocol, we'll call it protocol head, and it will be pause, and it will be next protocol. So that's that, and now finally the functions that we will expose are going to be so that is, sorry, that's RX. So this is the function that allows a packet to be received by the networking hardware. So this is the receive path into the networking stack. And we also have protocol packet, and we have next handler. Okay. The next thing that we want is the ability for a protocol to be registered. And finally we will have a protocol setup function. Okay, so this is the header. And this is the API. It's not very big. The protocols we'll use to interact with the protocol manager. So let's implement this. So we have protocol.c. So a few things that we're going to need. Packet.h, and we're also going to need protocol.h. And let's begin. So static list protocol head. So this is our list of registered protocols. So if you remember in the previous video we had two lists. We had the list of protocols that were registered, and we also had the queue of packets. So here are those two objects here, the list of protocols that are registered and also the queue of packets that are ready to be processed through the networking stack. So we have a mutex, and we also have we have a mutex and a condition variable that protects the packet queue. So let's do protocol rx packets. So this function is basically just going to lock the packet queue and append it to the list, and that's about it. So mutex lock. We lock the mutex, we add it to the list. One other thing that we're also going to have to do is add a list object into the packets so that we can actually chain the packets together. So let's do that. So let's go packet.h, and inside here we're going to need struct list, and we'll call it node, and we're also going to need the enum protocol handler. What did I call it? Sorry. Protocol type handler. So that's what is going to be handled by next. Okay, so those are the two augmentations to the packet objects that we need to facilitate the protocol manager. So let's go back to the protocol implementation. So okay, that inserts into the packet queue. We also need to wake up whatever is waiting on this list, and then we finally unlock the mutex. Okay, so that's our RX packet. It's really not that complicated. As I say, essentially all we're doing is just taking a packet that's passed into us and adding it onto that list. Okay, what about the inject TX? Again, very, very simple. Inject TX, so protocol type, that's the next handler. So what we would do is we need to say packet handler is equal to type, and then let's inject it. Mutex lock packet queue mutex. Let's add it to the list. Sorry. Okay, and finally unlock the mutex. Okay, so that's again essentially putting stuff into the into the protocol manager. So one thing we will do, that we can assert packet dir is equal to rx. Just make sure, again, it's not really too much of an issue, but they should, the correct function should be being called really. Okay. Next function is when we want to register an interface, register a protocol. So we're passed in a protocol to be registered. And all we do is we put it onto the protocol head. Okay, and that's that. That allows us to register a new protocol to the stack. So the next function that we're going to write is the actual function that the protocol manager runs. So this is, we're essentially going to have a set of threads that start moving these packets out of the queues and calling the respective callbacks. So we're going to write the actual task function now for those threads. And that's the next function that we will write. It's a static function because it should never be called externally. It's only ever going to be called internally. Again. Okay, great. So while one, because this is a function that should never return, we're gonna first of all, what these threads are going to want to do is get the next packet off the queue. So and then while the list isn't empty and then list first entry on and packet queue, type of packet, node. Okay. List remove, so remove it from the list. And finally mutex unlock. Okay, so essentially what we do here is we lock the mutex, we then wait on the condition variable, which if you remember the tx and rx functions signal the condition variable to wake up. So any threads that are sleeping or waiting on the condition variable are going to get woken up. We have this in a while to make sure that we don't have any spurious wake-ups, and also we pass in the mutex so that we make sure that we don't miss any signals, because it could be the case that if we don't lock the mutex and we wait on the condition variable that we signal before we wait, and then that signal will get lost. This is a way of protecting that to make sure that when the signal does come in, there is actually something waiting on the condition variable. So now that we have our packet, what we're going to do is basically run it up and down the protocol stack. So while the packet exists, now we're going to write this function. That's going to get our protocol that we want to call. So let's quickly write that function. So static struct protocol t, resolve packets protocol packet. Okay. If prototype so if the type is equal to the handlers, i.e. the next protocol that should be called, then we return the protocol. And if we couldn't find anything, let's return null. So down here, we say if we couldn't find the protocol, then panic, error could not resolve protocol. Great. So now that we have a valid protocol, what we want to say is, oh, got that guy, is if it's equal to receive, then call the protocol rx packets, else protocol tx packets, and after which, if the packet, so if the previous protocol called said drop, then we say drop, then we simply say packet destroy and packet. And that's pretty much it. That's all the tasks do. They basically, whilst they have a pick a packet off the queue, and then whilst we have a packet, just keep calling the appropriate handler, resolving every time the new handler until eventually one of them should set it to drop, in which case we destroy it, then we go back up here and wait for the next packet off the queue. It's as easy as that. And finally, the last function that we have to write is the function that sets up the tasks and actually spawns them off. So let's do that. Set up void, and then mutex init. Let's initialize the mutex. Convert. Okay, and finally we will define that somewhere else. Okay, and that's pretty much it. Let's just define this number of protocol workers. Let's say 3 for now. Okay, great. So the last few things that we have to do is call the setup function that we defined down here in main, which we will do, source main.c, and as you can see here, we have a main function that's called whenever the system starts. So let's call protocol init, and it's also going to need to see its header, which we can put here, hash include net protocol.h. And okay, so that's that. The other thing that we're also going to need to do is add this to the make file, which we can do here, source net protocol.c. So let's try and compile this. Okay, implicit declaration of protocol in it. I'm sorry, I called it the wrong name. I think I called it protocol setup, didn't I? Oops. And this is just missing a few headers, so we need assert.h, and I think we're going to need to include mutex.h as well as convar.h. Okay. Okay, there we go. We compiled. So that essentially is the protocol manager implemented. In the next video, we're going to actually start implementing the network drivers. So this will get us raw bytes out onto the wire. We'll use Wireshark to capture them from the embedded device so we can see real data being transmitted out of the network. And yeah, it should be a good one. So I hope you enjoy that. And yes, thank you very much for watching, and I hope to see you again soon. Bye.